Everything starts with Spring Initializr. Instead of manually configuring projects, we can instantly generate a production-ready backend with all required dependencies already configured. Spring Web for REST APIs. Spring Data, JPA for database access. Validation for request validation. And MySQL driver for database connectivity. This saves hours of manual setup and gives us a clean foundation immediately. Now let's organize the application properly. A clean Spring Boot project usually contains controller, service, repository, entity, DTO, and configuration layers. This architecture keeps applications scalable and maintainable. Next, we create our user entity. This class maps directly to the database table using JPA annotations, allowing Spring Boot to automatically handle object-to-database mapping. Now we move to the repository layer. This is where QueryDSL becomes incredibly powerful. Instead of writing fragile string-based queries, QueryDSL allows us to build type-safe queries with IDE autocomplete and compile time safety. That means fewer runtime query errors and much safer refactoring. Once the repository executes the QueryDSL query, it communicates with the database and fetches the required data. Next comes the service layer. This is where the actual business logic lives. Here, we call the repository layer to fetch or save data, and then we transform the results into DTO responses. For example, when fetching users, we convert user entities into user DTO objects before sending the response back to the client. To make the code cleaner and more readable, we use Java streams for mapping collections. And for handling missing values safely, we use optional instead of messy null checks. Optional makes the code easier to understand and helps avoid null pointer exceptions. Now that we have our layers set up, let's expose the API through a REST controller. In Spring Boot, the controller is the entry point. It receives incoming HTTP requests from the client, like GET or POST requests, and then delegates the real work to the service layer. The controller should stay clean. It should not contain business logic. Finally, the controller returns the result back to the client as JSON. We use ResponseEntity to properly control the HTTP response, including status codes and the response body. So the complete request flow looks like this. Client sends a request. Controller receives it. Service processes business logic. Repository executes QueryDSL queries. Database returns data. Controller sends JSON response back to the client. This layered architecture helps Spring Boot applications stay scalable, clean, and much easier to maintain as they grow. If this helped you, make sure to like and subscribe for more Spring Boot and Java tutorials. And I will see you in the next one.